Okay, let's look at a division problem here, 8a. We're looking at dividing 40 by negative 5. We're dividing a positive number by a negative number. Recall our list here that goes through the list of signs. We have a positive divided by a negative right here. Positive divided by a negative number is going to give us a negative result? So it's going to give us negative 8. Now you're doing this with a calculator. You actually put it in just like you see it. 40 divided by negative 5, negative 8. The next one is a multiplication problem. Negative 5 times negative 6. Well, we're asked to multiply two negative numbers here. Look at our tables here. You don't have to guess. Table of rules. Negative times a negative gives us a positive. So that's going to be a positive, 30. Negative 5 times negative 6. Okay, let's go to number 9 now. Number 9, we're asked to multiply here. It says evaluate. Negative 3 times positive 3 times negative 4 times negative 1 and a negative 2. Let's write that up. 3 times a negative 4 times a negative 1 times a negative 2. All three numbers are negative except for the first one. Now this is actually multiplication. When you don't see anything between the numbers, it's automatically understood to be multiplication. What I suggest to do is multiply 2 of them at a time. 2 at a time. Positive 3 times a negative 4, look at your rules here, gives us a negative 12. Times negative 1 times negative 2, a negative times a negative gives us a Positive 2. Now if you're multiplying a positive times a negative, we're going to get a negative 24. So that's how I suggest multiplying several numbers. Just multiply them 2 at a time. Number 10. Let's explain that one for you. I'm sure you looked over that, and if you had some questions, hopefully after viewing this presentation, you will better understand what you saw on the paper. It says to evaluate we asked to evaluate negative 4 to the second power. That's the way you read that. Negative 4 to the second power. What does this mean? It means to take this number, negative 4, and multiply it by itself 2 times. So that means negative 4 times negative 4. The negative 4 is multiplied by itself twice. What's a negative times a negative gives us a positive 16. All right. Okay, B. B is negative 3 to the third power. Let's take a look at that. Negative 3 to the third power. Negative 3 to the third power. I bet you understand what that means based on what we just presented in the last example. What does negative 3 cubed mean? Well, it means negative 3 multiplied times itself how many times? 3. Why 3? Because the exponent, that's what this is called, the exponent is 3. If the exponent was a 4, we'd have another multiple of negative 3, or another negative 3 to be times by all of this. Now remember what we said, we multiplied 2 at a time. So we're going to multiply these two first. What's the negative times a negative? It gives us a positive 9. And then multiply that by a negative 3. Okay, so what is a positive times a negative? It's a negative 27. Negative 27. So that's how we raise a base to a power. Remember that the exponent tells you the number of times to multiply the base times itself. And don't forget about your signs. When multiplying more than 2 numbers, multiply 2 at a time. Great. Hope that was helpful. Okay, let's go to number 11 now. 11 is a problem in which we're asked to do some evaluating here. We have this thing called a polynomial, and that's what this is. It says number 11, evaluate evaluate when x is negative 6. Okay, it says when x equals negative 6, what is this going to be? X squared plus 7x plus what? 4. What that means is, when I put negative 6 where I have that x and do all the things it says to do, what number am I going to get? Well, let's do that first of all. Everywhere I have an x, I'm going to put negative what? 6. Now 7x means 7 times x. Okay? So x has to be replaced with negative 6 and then plus what? 4. Now remember the order of operations. We do the exponents first. Remember that song? It goes, please excuse my dear Aunt Sally, PEMDAS. Says that we do the exponents first. What does negative 6 squared mean? Negative 6 times negative 6 plus 7 times negative 6. I'm just bringing the rest of it down. Here I just broke that down, if you will, expanded that. And now we'll work through it. I have a multiplication I'm going to do here, multiplication here, and then add. Here multiplying a negative times a negative will give us a positive what? 36 plus a positive times a negative gives us a negative 40 what? 2 plus 4. Now we get down to adding. I'm adding different signs, right? I'm adding different signs, adding different signs. We take the sign of the biggest, since 42 is bigger than 36. Take that sign and then what? Subtract. So I get negative 6. That's this addition here. Plus the what? 4. Here I added 36 plus a negative 42 and got negative 6 plus 4. Signs are different. Negative and a positive that I'm adding. Take the sign of the largest number, which is minus, and then subtract 4 from 6, and you get what? 2. Or you can think, which do I have more of? I have more negatives, so the answer is going to be negative, and then subtract. Addition, more negatives, sign is negative, and subtract the numbers. I have a little song that goes something like, when adding numbers with different signs, take the sign of the largest, then subtract them. That might work for you too. It's a nice little song. Try that. Adding numbers with different signs, take the sign of the largest, then subtract them. You might like that. Okay, let's go to the next problem. The next one is number 12. Number 12, we're going to be looking at adding some fractions. Now I know everybody's had a chance to at least get to those fractions in, or should have got to those fractions by now. So let's take a look at number 12. We're adding fractions, and the fractions are 2/3 plus 1/5. 2/3 plus 1 what? 5th. Step number 1, find the LCD. Okay, how can I get the LCD? We can multiply our denominators 3 times 5. So we multiply these things and get what? 15. That's how we can get that common denominator. And what does this mean now? I need to get a 15 here, so I'm going to multiply this by 5. I need to get a 15 here, I'm going to multiply this by 3. Multiply this by 5 to get 15. Multiply this by 3 to get 15. And whatever you do on the bottom, you do to the what? Top. So here's what we do. Look. How's that's going to look? 2/3 is going to be multiplied by 5. Why? Because I'm trying to get what? 15 in that denominator. Whatever I do to the bottom, I do to the top. Plus, remember I need a 15 here also. I need 15 here also. So multiply this by 3. Whatever you do to the bottom, you must do to the top. Now we do the multiplications and watch what we get here. 10 over what? 15 plus 3 over what? 15 gives us 13 over what? 15. Done deal. Not bad at all. Follow that sequence, and adding fractions is pretty easy. Not too difficult. All right, let's go to number 13. Number 13, we're asked to multiply two mixed numerals, and we're going to write the answer as a mixed numeral in simplest form. So let's go ahead and take a look at that. And the mixed numerals are 2 1/2 times 1 4/5. Let's write that up. 2 1/2 times 1 4/5. Here's the procedure. What we do is multiply the whole number times the fraction by times the denominator and add the numerator. So 2 times 2 plus 1 all over my denominator of 2 times, again, 1 times 5 and then add 4. 1 times 5 and then add 4 to that and put that over what? Our denominator 5. Do our multiplying and adding here, we end up with what? 5 over 2 times what? 9 over what? 5. Now here we can cross cancel. Look here, we have a 5 here and a 5 here. 5 goes in 5 one time. 5 goes in 5 what? One time. And we can multiply 1 times 9 and get what? 9. And then 2 times 1 gives us 2. So the answer is 9 over 2. Now they want us to write this as a mixed numeral. So let's go over here and divide the bottom or denominator into the numerator. 2 goes into 9 4 times, multiply 4 times 2 and get 8 with a remainder of what? 1. 4 times 2 is 8. So how do we write this answer? The answer is 4, the remainder, over the divisor. 4 1/2. That's why you write the answer. 4 1/2. That's how you write that division problem. Okay. Let's go to our next problem. Here we ask number 14 to subtract two mixed numerals. Well, if you can add, you can subtract. Yes. Let me show you. If you can add, you certainly can what? Subtract two fractions. You'll need a common denominator again. We showed you how to find that. So let's take a look at this one. It is subtract 1/3. I don't know that we'll need our rules. Let's go ahead and get rid of our rules at this point. We may refer to those later on, but you have them down. I think you'll be fine there. Use this whole board now. Let's take 1/3 and subtract from it the fraction 1/4. Just like with the addition, we need a common denominator. How are we going to get that common denominator? Remember, we multiply 3 times 4 to get what? 12, and that's our LCD. You know what that LCD stands for, least common what? Denominator. Now what does that mean? It means I need a 12 here and I need a 12 here. Well, how are we going to get that 12? Well, 3 times what is 12? 4. So I'll multiply this one by 4, and whatever you do on the bottom, you do to the top. I need a 12 here. I have to have 12 in both of these cases. 4 times what? 3 is 12. So if I multiply this by 3, I must multiply this by 3. So let's do it. It's going to look like this, guys. Step 2, 1/3. I need a 12 here, so multiply by 4. Yes, 3 times 4 is 12. Multiply the top by 4. Minus this time, 1/4. I multiply 4 times what? 3, and the top times 3. Do our multiplying. 1 times 4 is 4. 3 times 4 is 12. Minus 1 times 3 is 3. 4 times 3 is 12. Do the subtraction. Remember how we subtract fractions? We keep our common denominator, and 4 minus 3 gives us what? 1. That wasn't too bad. Very much like addition. Yeah, so if you can add, you can subtract. You'll need a common denominator and move through the problem, just like we did in addition. Okay, let's look at number 15 now. Number 15, we're going to look at mixed numerals again, and in this particular example, we're going to divide mixed numbers. Well, if we can multiply, we can kind of divide. It's kind of the same procedure. There's some similarities there. But if you understand multiplication, then you certainly understand how to do division. The problem reads 4 2/3 divided by 4 1/2. 4 2/3 divided by 4 and what? 1/2. Now remember what we do here. First step is to change these to improper fractions. I'll state what we do here. Remember, multiply the whole number times the denominator, add the numerator, so we get here 14 over what? 3. 4 times 3 is 12, add 2, you get 14. Divided by 4 times 2 is 8, add 1 and you get what? 9 over what? 2. Now, the word we use here is keep, multiply, and flip. That's what I'm going to do now. Keep, multiply, and flip. That's what I'm going to do next. That's step 1. Step 2, I'm going to keep this fraction, the first fraction, multiply, and flip the second fraction. Like that. That's pretty cool. Division, keep, multiply, and flip. Now what do we do? Well, we can't do any canceling here or here. Multiply straight across. 14 times 2 is what? 28. 14 times 2 is 28. Then 3 times 9 is what? 27. Remember to multiply fractions. Your basic rule is to multiply the tops and then multiply the what? Bottoms. Or the numerators and the denominators. Now we want to convert this to a mixed numeral. So let's divide 27, the denominator, into the numerator. It goes one time. 1 times 27 is 27 with a remainder of what? 1. So remember how we express this answer. So this is equal to, let's put it up here, 1 and 1 over 27. 1 and 1 over what? 27. That's the answer. That's how we got that answer that was on that paper. I'll follow those steps, study it, and anytime you divide mixed numerals, you can use that procedure. Okay, now we're ready for a really good problem here. In this next example, we're going to be asked to solve an equation. Now, you all did a very good job on presenting two-step equations. Remember, we had those discussion questions, and you did a great job there. So this one has a little meat in it, a little bit involved. So let's go ahead and solve this thing. It reads negative 3 over 2 equals negative 2/7 x minus 9 over what? 5. Now to save time, I'm going to show you a strategy that can be used. You can just go ahead and the procedure I want to use is to eliminate the fractions. So in order for me to eliminate all these fractions, get rid of them, I'm going to multiply these denominators. That'll be a good thing to do. And that gives me what? 70. This is going to give me a common what? Multiple. Or common what? Multiple. Okay? And what am I going to do with this common multiple? I'm going to take this number 70. That's where that 70 came from. That you saw on the paper, step 2. I'm going to multiply all of these by 70. So 70 times minus 3 over 2 equals 70 times minus 2/7 x. And then minus 70 times 9 over what? 5. So I multiply all of these by 70. 70 times this one, 70 times that one, 70 times this one. Notice all my original terms are in parentheses. All the original members of the equation are in, this equation is in parentheses. Now I'm going to show you something here. We wanted to eliminate the fractions, so we say 2 goes into 2 one time. 2 goes into 70 what? 35 times. How about this one? 7 goes to 7 one time. 7 goes to 70 what? 10 times. How about this one? 5 goes in 5 one time. 5 goes in here, I believe it's what? 14 times. No more fractions because they all over what? 1. Now, what are we going to do? Let me tell you first. 35 times minus 3. 10 times negative 2x. Negative 14 times 9. I'll write that up for you. Third step. We're going to have what? 35 multiplied by a minus 3 equals 10 multiplied by minus 2x minus 14 multiplied by 9. No more fractions, as I stated. Let's do the multiplication now. Remember, a positive times a negative